So that would be the reasons why we need to study STS. Now we proceed to important information about science and technology. So at this point, we'll talk about each of them separately. What is science? What is technology? And what is society? So we can understand the study of STS a little bit better. So let's begin with what science is. What is science? Science comes from the Latin word scientia, and this means knowledge. Science also refers to a system of acquiring knowledge. So we can see at this point that science is knowledge and science is also a system. In addition to that, science also refers to the organized body of knowledge people have gained using that system. So it's not simply knowledge, but organized body of that knowledge. And there's another definition for science. It is systematic way of learning about our natural world. Now, what is interesting about this definition that you need to memorize is the fact, are two important words here. First word is systematic. So it's orderly. There is a pattern when we say learning, so that would be getting information, getting knowledge, and also the systematic way of learning is about the natural world. What we mean by this is that the natural world can be detected by the five senses, our eyes, our nose, our sense of taste, our sense of touch. So these are the different senses, and the natural world can be detected by these senses. But for example, during the Middle Ages, there was this particular scholarship, a scholars problem, where scholars were debating, and the question was, how many angels can dance on top of a head of a pin? So, in terms of science, it will not be able to answer this question, how many angels are dancing on top of the pin. It's because angels are not part of the natural world. They are part of the supernatural world because they cannot be detected by the five senses of our body. So, we leave this kind of question to religion or perhaps to metaphysics, maybe even philosophy, but this cannot be answered by science. So that is why science only deals with what we call as the natural world. Another thing, let's look at some definitions of science. Science can be defined as an organized, hierarchical activity that investigates nature and human nature by experiment and observation. So you will notice a lot of new words here. One is experiment. So science is a result of experimentation and observation. And science is, as we mentioned in the beginning, is shaped by social forces, historical change, and also shapes culture as well. Now, here are some other important characteristics of science. What is the content? The content of science is the body of organized knowledge about nature. So we talked about that a while ago. Scientia means knowledge. The method of science is obtaining that knowledge through experiment, observation, hypothesis, theory, and laws. The attitude of those who do science is organized and systematic skepticism. When we say skepticism, it means doubt. So the things around us, we doubt them so that we can have a way to answer the question or to get the real answers for our question. So one example would be the question, why is the sky blue? Well, when we were children, oftentimes we might be thinking that it is a reflection of the ocean. That is why the sky is blue. So this is one of the possible explanations or what we call as hypothesis. However, we cast doubt on this and we try to test this hypothesis or this possible answer. We do not simply accept blindly these answers, but we test the answer so that we can really go to the real answer. We can go to the real heart of the matter. So the question again, why is the sky blue? Well, the answer to that is when scientists were able to discover that the atmosphere contains a lot of dust particles, contains gaseous particles as well, and water droplets that are suspended in the air. And then white light that comes from the sun is actually made up of several colors, and we are familiar with this Roy G. Biv: red, orange, yellow, green, blue, indigo, and violet. And when this white light coming from the sun that is composed of several colors passes through our atmosphere, the dust particles, the gaseous particles, and the water droplets act like prisms, causing the light to scatter. But not all the light or the color scatter. It is only the blue light that is scattered by these prism-like substances or structures such as the water droplets and the gaseous particle. Since it is only color blue that is scattered as the light passes through the atmosphere, thus our atmosphere becomes color blue. So that's the reason. So the attitude is organized and systematic skepticism. Now, what is the goal of science? The goal of science is to explain, for us to understand, to make predictions, and be able to control things somehow. As for the example a while ago, why the sky is blue, science tried to explain that, and that would be the goal of science. Now, in terms of language, the language of science is mathematics and technical vocabulary. In physics, you are very familiar that when we say speed, speed will be distance divided by time, which is a mathematical formula. When we say acceleration, it will be velocity divided by time. So the language of science will involve a lot of mathematics as well. Another example would be if you're familiar with the theory of relativity, which was expounded to us by Einstein, Albert Einstein. For those who are very knowledgeable about this subject, there are a lot of mathematics that try to prove the theory of relativity. And if you are familiar again with Albert Einstein's E is equal to mc squared, it tells us that energy is equivalent to mass times the velocity of that mass squared, which means that matter and energy can be converted from one form to another, from energy to matter and matter towards energy. So all of these are actually mathematics and technical in their vocabulary. Another characteristic of science when it comes to tools, science uses a lot of instruments and a lot of technologies. If you would like to measure distance, you have to make sure you have a ruler. If you need to measure time, you have to have a clock. If you need to measure the velocity, you have to make sure that you have a meter, you have a way to measure the distance and also to measure the time. So in science, tools, instruments are very important. When in terms of community, there is discipline, there is education, credentials are important among scientists, careers, there are patrons or those who would like to help in research, societies, and also turfs. In terms of process, in science, it is organized but very diverse activity shaped by social forces and also historical change. Now, it is important for us to know that there are two kinds of sciences. That would be basic science, and the other one would be applied science. So let's define both of them. Now, for the basic research or the basic science, these are the thinkers. The characteristics of this type of science is characterized by the following. It is simply to discover basic facts with no immediate focus on solving real-world problems. So in other words, ang basic research, basic science, ang pinakalayon lamang ay malaman o makaalam ng bagong impormasyon na hindi iniisip kung ano ang magiging aplikasyon nito sa totoong buhay. So that will be the characteristic of basic science. It is simply knowledge for knowledge's sake, and it is speculative, often takes decades of cumulative knowledge to benefit society, but breakthroughs can lead to paradigm shifts. So ang pagpapatong-patong, ang pagdami ng impormasyon at kaalaman would eventually lead to a paradigm shift o pagbabago ng pananaw, pagbabago ng kaisipan, pagbabago ng mga karaniwang bagay na pinaniniwalaan at ginagawa. And we'll be talking about these paradigm shifts in the next coming discussions. Now, for applied research or applied science, these are the doers. It is characterized by impacting real world problems relatively quickly but focuses on incremental science rather than breakthrough. So there are two things that we can take note here. Ang pinakalayunin ng applied research, applied science ay bigyan ng solusyon ang mga problema sa mundo ng mabilisan or fast. At the same time, ang applied science or research din ay nakafocus o nakatuon na ito ay paunti-unti na dumadagdag rather than breakthrough. So paunti-unting mga innovations, paunti-unting mga pagbabago, paunti-unting mga changes para which actually doesn't lead to immediately into breakthroughs. Now, applied science can also be characterized by the fact that it is relevant and has immediate contribution to real world problems as we mentioned a while ago. So may kaagaran itong contribution, may kaagaran itong nabibigay na benepisyo sa mga tao sa buong mundo. Now, some examples of applied research or applied science will be the invention of the internet, which solved immediate problems with communication. At that time, the Cold War was still ongoing between uh, the USSR and the United States of America. So the military developed a form of communication where the message or the information are cut into several pieces, and these pieces would go through a network of communication lines, eventually reaching its target point, and the message would be put together back in that particular place. So this is the beginning of the internet, and this has great impact to us right now. So the prominent difference between basic and applied science would be that basic science simply pursues knowledge for knowledge's sake. It doesn't think about any kind of application, while applied science has already an application in mind during the course of the research or during the course of doing the science. So as we can see in this comparison, pure science, another name for basic science, is just whenever one is curious about something and experiments done just simply to find the answer. So we can see here that the uh, pure science or basic science is simply a thirst or a pursuing of knowledge for knowledge's sake, while applied science is different because it is applied to humanity and the outside world. And some of the examples or frequent where it is frequently used would be in the medical field for things like vaccines, antibiotics, new medicines to help humans become more immune to harmful bacteria and viruses that we are exposed every day. So these are just a few of the examples of applied science. Now, here are some branches of science which would fall under either pure sciences or basic sciences and also applied sciences. So let's look at this. For biology, for pure sciences, for biology, botany, anatomy, zoology, genetics, marine science will all be under pure science, looking for knowledge's sake. In physics, the physicists, the biophysicists, the geophysicists, astronomers, meteorologists, mathematicians, all of this would also be under pure science. And for chemistry, the chemists, the biochemists, and the geochemists will be doing pure science as well. For the applied science, it will be under physics, nanotechnology, forensics, environmental science, kinematics, medical microbiology, and many others will be some examples of researches or science done under the applied sciences.